Hey there, and welcome to this explainer. If you're the kind of person who geeks out over seeing just ordinary, everyday things totally re-engineered by tech, well, you are in exactly the right place. Today, we're taking something seriously mundane, literally just the act of throwing something in the trash, and we're going to look at how it's morphing into this high-tech marvel right under our noses. We are talking about the smart bin revolution, and honestly, it's absolutely fascinating.
So I want you to kick things off by just asking yourself this. What if your average public trash can was actually a robot? Okay, I know, it sounds kind of like science fiction, right? But I want you to reimagine street-level waste collection not as this, passive, stinky chore, but as a highly dynamic, data-driven ecosystem. We're moving away from a world where a bin is just a metal box sitting on a sidewalk and moving into one where it's actually a critical node in a smart city's network.
Okay, let's dive into this. Here's our structural roadmap for today. First, we'll cover the smart bin revolution itself. Then we'll go inside the technology stack, walk through the step-by-step sorting process, look at city benefits and deployments, and finally, wrap up with the challenges and future upgrades.
All right, part one, the smart bin revolution.
To really grasp why these high-tech receptacles are stepping up as the ultimate heroes in our push for sustainable, zero-waste cities, we gotta look at our core definition. So a smart street recycling bin is, at its heart, an active, intelligent machine. Think about a traditional bin for a second. It's completely passive. You throw mixed waste in, and it all just inevitably heads straight to a landfill, or it requires incredibly costly manual sorting way down the line. But smart bins, they're totally different. They are packed with AI, IoT sensors, cloud connectivity, and internal robotics. They don't just hold your trash, they actually identify it, sort it, communicate their status in real time, and actively work to reduce our carbon footprint.
Moving right along to section 2, inside the technology stack.
Let's peel back the layers here. We're moving from the physical shell to the digital brain that powers the whole shebang. The anatomy of a smart bin is essentially this beautifully layered architecture of cutting-edge hardware. Right at the perception layer, you've got HD computer vision cameras snapping pictures of the items. Then you've got IoT sensors, specifically ultrasonic or infrared ones that can measure the fill volume of a compartment with crazy precision. We're talking down to just 1 or 2 centimeters. Plus, there are temperature sensors checking for fire risks or organic decomposition. All of this data gets beamed out via 4G, 5G, or low-power networks like LoRaWAN. They've even got e-ink displays and LED rings that actually turn green when you sort something correctly, which gives you this nice instant behavioral feedback. Oh, and the best part? A lot of them are totally off-grid, just running on roof-mounted solar panels.
And this brilliantly illustrates one of the absolute most powerful features of that hardware stack. Because these bins can be equipped with solar-powered internal compactors, they can physically press down the waste once it hits a certain threshold. This single feature, just the compactor, can increase a solitary bin's capacity by up to 5 to 8 times. 8 times. That means way fewer garbage trucks out there clogging up city streets.
All right, section 3, step-by-step sorting process.
To really visualize this, let's follow a little micro-narrative, the journey of a bottle. Here's the 4-step physical sorting process when you toss an item. Step 1, you walk up to the bin and drop in your waste. Let's say it's a plastic water bottle. Step 2, this is where the magic happens. The camera captures an image, and the AI engine instantly classifies it as PET plastic. It even checks to see if there are residual liquids or contaminants inside. Step 3 is the robotic sorting decision. A mechanical gate, or maybe a rotating drum, literally directs your bottle right into the specific plastics compartment. And finally, step 4, confirmation and data log. The screen on the bin flashes a green checkmark to thank you, while simultaneously logging the time, the material type, and the new fill level increment straight to a cloud dashboard.
Now, what's really interesting here is the sheer speed of that edge AI processor. This whole operation, it's powered entirely on board. It makes that complex sorting decision in just 100 to 300 milliseconds. It is literally a blink of an eye. And because all this processing happens locally on the edge, right there inside the bin, it cuts down on latency. But even more importantly, it ensures strict data privacy. So, raw images of you or your trash aren't just being endlessly uploaded to some centralized cloud somewhere.
Okay, let's move into section 4, city benefits and deployments.
So this tech is amazing on its own, for sure, but when we shift our focus to the real-world ripple effects, we see exactly how it optimizes municipalities and actually rewards us, the citizens. When we compare the dual impacts here, the results are just massive. By continuously monitoring fill levels, cities can dynamically optimize routes for their collection trucks. And that's not just a minor tweak, we're talking about huge fuel and labor savings of up to 40%. For us, it means no more walking past overflowing, foul-smelling bins. Automatic sorting drastically cuts down on contamination, which preserves the value of the materials for the city while giving citizens a simple one-hole deposit experience. So, no more standing there confused about whether you need the blue bin or the green bin. Plus, through gamification, cities get higher overall recycling rates, while citizens can actually earn points or credits just for throwing things away properly. Talk about a win-win.
And hey, this isn't just some abstract concept. It is happening right now, all across the globe. Let's rapid fire through some really cool examples. Over in Poland, a system called Bin-E is doing 4-category AI sorting straight inside office buildings. In the US, Big Belly stations are bringing solar compaction to the busy streets of New York and Boston. In South Korea, E-Cube Labs is deploying these awesome ultrasonic multi-compartment units for high footfall areas. Clean Robotics back in the US has developed TrashBot specifically for busy indoor spaces. And in Singapore, they're integrating smart bins into a massive national reverse vending reward ecosystem where people actually get credits for recycling their beverage containers.
Just to highlight how effective these systems actually are, take TrashBot for example. It's deployed in super messy, high-traffic areas like airports, and it achieves over 90% sorting accuracy. 90%! Think about that compared to the accuracy of a hurried human rushing to catch a flight. The AI vastly outperforms human sorting, which really just proves this technology works, even in the most chaotic, fast-paced environments.
All right, bringing us to Section 5, Challenges and Future Upgrades. Look, no revolution is without its roadblocks, right? We have to be real and address the current hurdles of deploying this tech today before we go peering into the wild, futuristic horizon. Scaling this up definitely has its challenges. First off, high upfront capital costs. I mean, you are essentially buying computers, sensors, and robotics instead of just a plastic bucket. Then there are environmental factors, mechanical wear and tear from extreme dust or heat, and the very real struggle of keeping those solar panels charged during long, dark winters. But honestly, the funniest yet maybe the most difficult challenge? Designing for human error. Just imagine trying to train a state-of-the-art neural network to handle the messy reality of someone casually tossing in a half-full coffee cup. The AI literally has to figure out what the cup itself is made of, all while dealing with the liquid sloshing around that could contaminate the entire bin. But overcoming those hurdles? That leads us straight into an incredible future. Let's look ahead and see how this builds out, because the smart bin is evolving fast. We're going from stationary bins to roaming autonomous bin robots that will actually roll right up to you in a pedestrian zone to accept your recyclables. We'll be moving from standard visible light cameras to near-infrared spectroscopy, which can identify exact plastic polymer types with near 100% accuracy. And the most mind-blowing part? Moving from distant municipal processing facilities to local micro-recycling. Yes, we are talking about smart bins that basically act as a mini factory on the sidewalk. They could grind and clean PET bottles right on the spot to produce plastic flakes that are instantly ready for 3D printing filament. Crazy, right?
So, I want to leave you with this final provocative thought. By embedding intelligence directly into that very first point of disposal, the bin is no longer just a bin. It's an educator, a compactor, a sorter, and a vital data node. Once we fully integrate this into a circular economy, the simple act of throwing something away will become a measurable, meaningful contribution to a cleaner planet. We are quite literally turning our trash into a treasure trove of data and resources. Well, thank you so much for joining me for this explainer. I really hope you found this deep dive into the smart bin revolution as exciting and eye-opening as I do. We are witnessing some truly incredible innovations driving our smart cities forward. For more, visit our website, Ferris Solution. Keep learning, stay curious, and I will see you in the next explainer.